Irrigation System using IoT project assignment for Skyfi Labs online course. The idea of Smart Irrigation System is to irrigate plants, land, crops, and any other vegetation based on sensor readings of the soil moisture sensor while having remote access to the system via internet. This enables real-time data logging and, more importantly, remote access and control on water usage. Thus, it makes the irrigation system smart because it is much more efficient and timely than traditional methods of irrigation. It is completely driven by real-time conditions which help real growth of crops. This project is a small-scale implementation of the smart irrigation system. Any IoT project consists of the following components: group of sensors or sensor networks to acquire data from real world, embedded systems that drive the entire physical system of the IoT environment, communication network and necessary protocols to send the data to the internet, and finally, analysis and appropriate representation of the acquired data. Correspondingly, the components used for smart irrigation project here are the soil sensor module to record the moisture content of the soil at all times, Arduino Uno that acts as the brain of the entire system, motor driver and pump that is used to irrigate the soil as needed, and the ESP8266 Wi-Fi module that receives and transmits data from Arduino via serial communication for data analysis and representation. If we move further into the technical aspects of this project, here we have the soil moisture sensor. It consists of the YL69 probe and YL38 interface. They both make up a resistance sensor that is often used to measure soil moisture. YL69 probes are used to measure the resistance of the current in the soil. Greater the moisture content, lesser is the resistance of flow of current, which implies lower output voltage. On the other hand, when the soil moisture is low, the sensor outputs a high level of resistance, which implies higher output voltage. This analog voltage output is what is measured for appropriate action. This is a water pump. The microcontroller and Arduino run on 5 volts. Motors generally need 9 volts to run. The motors also need higher current than what is available from Arduino. For this purpose, we are using a controller circuit called the motor driver. The motor driver circuit acts as an interface between Arduino Uno and the motor. It provides the power required for running the motor. Coming to the components interfaces, the important connection pins that is used to implement the project are the A0 pin from the soil moisture sensor connected to the AA0 A0 pin of the Arduino is used to read the analog data from the soil sensor. Pin 8 of the Arduino connected to the motor driver input is used for activating and deactivating the water pump. Pin 3 and 4 of Arduino connected to ESP8266 RX and TX is used for serial communication to receive and transmit data from ESP8266. Other components, namely ThinkSpeak Cloud as seen in the screen and Virtuino app on smartphone, is used to capture and reflect the soil sensor data and pump status continuously. The Virtuino app on the smartphone alarms the user via beep and SMS when the soil moisture falls below the given threshold, which the user can make use for appropriate actions. The ThinkSpeak's APIs, channel ID, write and read keys are used to set up these features. The project working is as follows. Once powered up, the soil sensor records the moisture content in the soil at all times. It then sends the same to the Arduino, which is the microcontroller code. If the moisture level of the sensor falls below the given threshold, then the water pump automatically switches on to irrigate the soil. All the logic is preloaded as a software program onto Arduino Uno board to facilitate the working of the system seamlessly. In conclusion, additional features that can be used to extend the project are controlling the water pump from a smartphone or adding more sensors. Thank you.